Hello, so today we'll be doing something very small and simple, that is continuity. Simple logic, no breaks. Remember that it should have no breaks. Means, let's say if I have a graph like this and like this, and something like that. So if you see at this point, let's analyze this point. So here there is no break in the graph, so at this point we say the graph is continuous. But let's see at this point the graph breaks, so we will say at this point, let's say at this point it's discontinuous. Okay, so logically, just don't think logically, very logically, at this point, let this point be C. Let's move a little bit ahead of C. Let's say this point. This will be what? C plus epsilon. Let's see, we see this point. This will be what? C minus epsilon. So if we see the value at C minus epsilon is not equal to that. So f of C plus epsilon not equal to value of C minus epsilon. So how do we check a graph is continuous? What is very similar to this? Yeah, we check if LHL is equal to RHL. If LHL not equal to RHL, that means it is a discontinuous graph. It is as simple as that. Or just draw the graph. Draw the graph. Because I told you in the first thing that you should know how to draw the graphs. If you know how to draw the graphs, this becomes very easy and you don't have to do this LHL equal to RHL. The calculation might go out of hand. So let's say we have to prove 4 minus x square. Okay. Is it continuous at -2 and 0? Okay. So let's do the LHL at 0. LHL at 0 will be what? It will just be 2. RHL at 0, it will be 2. I'm not telling how I'm doing this so fast. You have to know it before, if you have done limit. If LHL at 2, what will LHL be at 2? LHL at 2 does -2, sorry. LHL at -2 does not exist, or RHL at -2 is just 2. Does not exist because this graph looks like this, and beyond this point there are no other values. There is no value here and there is no value here, right? So does not exist. So LHL is not equal to RHL, so it is discontinuous here and continuous here, which is very logical. Okay, so remember this, all those rules of sum. So let me rest. Sum minus k into the function, product like f into g, f by g, f to the power n, all exist for continuous. So if both are continuous, these things will also be continuous. Okay, you can just prove it, it's not a problem. Also FOG is also, FOG and G of f are also continuous. So because this is very logical, right? So for example, let's say if you have a graph like this, then the next graph is something like this, the totality of that graph will always be continuous. Okay, so yeah, so this is very obvious. And yeah, so now we talk about one very important theorem, that is called the IVT theorem, or intermediate value theorem. Intermediate value theorem, what it says is that, so in a closed interval AB, if f is continuous and y0 belongs between FB and FA, then y0 is equal to f of c for some C belongs to AB. This is very logical. So what it means is that between, if let's say you have a graph, right? Let's say, but this is my A, this is my B, and it is continuous between A and B. So this part is continuous. That means if you take any point here, it will have a value. That simple as that, nothing else. So it will have a value. If it is not continuous, like if, like for example, let's say let's continue this like here. So if that was not continuous, you would not have a value here at this point, right? So yeah, that is like what we kind of find here. Okay, so yeah, so this is continuity basically, nothing else. And we can extend things to not be continuous as well. So for example, let's say if we have this curve, right, that earlier curve we made, right, it's not continuous in this range and this range, right? So if you make the function something like this, f of x is equal to root of 4 minus x square or 0 when mod x less than equal to 2, else. So what will happen, this will be continuous. See, this value will be 0 here. So this becomes continuous if I add this condition. So this thing is called a continuous extension. So yeah, this is the only thing you need to know about continuity. There is nothing else you need to know about continuity. This is all about continuity.